Automobile Final Assembly Plant Case Study Presentation. So, the goal is to conduct a comprehensive analysis for the design of a new automobile assembly plant, which is capable of producing about 60 cars per hour. The analysis determines the required number of workstations, specifies material handling systems, and calculates the total plant floor space. Some key findings were that the workstations, we need a total of 453 workstations, 440 manual, 13 robotic, are required across the 3 main departments. And the total required facility size is approximately 1,013,500 square feet. So problem statement. So the problem for the case study is to design a final assembly plant to meet a production target of 150,000 cars per year. Some operational parameters we encounter in the case study are that the production rate, you need 60 automobiles per hour. Cycle time is going to be 1 minute per station. Operations, the plant will perform assembly only. No parts manufacturing will occur on site. And the plant will operate 1 10-hour shift per day, 5 days per week. Right? So the plant workflow, the plant is organized into 3 major departments, plus a reprocess area with large storage buffers to decouple like the main stages of production. The plant is organized like this: the body shop, storage buffer, paint shop, another storage buffer, the trim chassis final, and then the reprocess area. So here's the analysis for the body shop. The body shop is a highly automated department focused on spot welding the car's frame. Workstations required, you need 73 total, 63 manual stations, and 13 robotic spot stations. Floor space is going to be about 91,000 square feet. And some key features of this area is the RoboGate framing system for initial welds, the synchronous transport conveyors for precision, and the 2-car storage buffers to manage the internal flow in the body shop. All right, next to the paint shop. And the analysis for the paint shop goes like this. The paint shop consists of a series of chemical processes, painting stations, and long drying ovens. You need a total of 127 workstations in the paint shop. Total floor space is going to be about 221,000 square feet. And some key features here is the automated dip tanks for the phosphate and prime coats. Extensive conveyor lines, for drying 15 minutes, drying for about 15 minutes, and cooling, which are about 10 minutes stages, and 10,000 square foot repair loop for the paint defects. And then after the paint shop comes the trim chassis final. This is the analysis for this area. This department is the most labor intensive, where all main components are assembled into the car. This station, you're going to need 253 stations and a total floor space of 430,000 square feet. This is the largest number of workstations and the largest floor space required in the plant. Some key features here are the highest direct labor requirement at 14 hours per car, no automation, all assembly is manual, and a high average manning level of 3.5 workers per station. So the material handling system, the facility needs a multifaceted system. It's required to move vehicles efficiently and rapidly throughout the system, throughout the facility. So some of the things that are part of this material handling system is work carriers. Standard 20-foot carriers are used from the body shop start until the final 10 stations. And there's also going to be conveyor types such as synchronous transport is going to be used. That's going to be mostly in the body shop for precision welding. Continuous transport is going to be used in the paint shop and the trim chassis final. And also chain and floor transport, which is going to engages the cars on their own wheels for the last 10 stations. And then storage buffers are going to be critical for managing downtime and sequencing some of the parts. The storage buffer between the body and paint shop is going to have a 45 car capacity, and the storage buffer between the paint shop and the trim chassis final is going to have a 210 car capacity. So this table summarizes the total calculated needs for the entire facility. Body shop, like I said, 73 workstations, about 91,000 square feet. Paint shop's going to have 127 stations, about 221,000 square feet. Trim chassis final is going to have about 253 workstations and 430,000 square feet. Other areas includes like the restrooms and the office spaces. They're going to include about 271,500 square feet of floor space. So other areas include everything that's not the stuff that's listed. And then total, like I said, it's going to be 453 workstations and 1,013,484 square feet. So some final recommendations is to construct a facility of approximately, like I said, 1,013,500 square feet to house all production, administrative, and logistical operations. You want to make sure the plant has a total of 453 workstations allocated and you allocate them as such, with 73 in the body shop, 127 in the paint shop, and 253 in the trim chassis final. And you want to implement a mixed material handling system using synchronous conveyors for welding, continuous conveyors for assembly, and a chain to floor system at the end of the line. And you want to install some large capacity storage buffers, 1 for 45 cars and 1 for 210 cars between the major departments, between the body shop and paint chassis, and between the paint and the trim chassis final. And you want to do that to ensure production continuity. Yep, and that's it. Thank you.